Hey all, a very good evening to all of you. My name is Rahul KANYAL and I'm going to take the discussion further, and we are going to talk about forming parts 2, 3, and even if you have not subscribed to our channel, you can hit that subscribe button. You can share this video to others so that others can also be benefited through these free online videos, right? And a very cordial welcome, guys. Okay, now this is about me. So I'm a senior faculty for Mechanical, GATE and ESE. My name is Rahul KANYAL. Now I take concept on fingertips production classes Mondays to Friday, every day at 2 p.m. Okay, please do join us there, and we also talk about the basics that are needed to clear exams like GATE and ESE. Okay, now we have from June to 2 we are calling it impossible offer, 2-year green card for these examinations. All right, now yes, till now we have had a discussion about forming, right? We have discussion about forming. We said that it can be done in ambient temperature, that's called cold forming, right? And it can also be done in hot temperature, and we are calling that hot forming, right? So hot forming is done in recrystallization temperature, right? So I'm going to just write it again over here. So that's nothing but recrystallization temperature. Yep. Now this figure is what is this? Is it a hot forming or a cold forming? Obviously, as you can see, this one is hot forming over here, right? So this one is hot forming because it is red hot here, right? So this is red hot. Okay, chalo, now let's talk about rolling today. All right, guys. So I'm going to just see you an animation of rolling. All right, so quickly let's see this. Now this is the raw material, a sheet or a plate. All right, now this is fed into rollers. Okay, now it can also be hot and cold. All right, so hot and cold, again guys, same things. Okay, so what is happening here is this is the direction of rollers. All right, now once we pass this let's call it a plate. Okay, once we pass this plate onto the rollers, the thickness here gets decreased and the grains also become refined. All right, now it can also be a cold forming, okay, like this. Is it good? The mechanism and the concept and theory here is exactly the same, okay, except that hot forming is done at recrystallization temperature and cold will be done at room temperature. All right, so cold will be done at room temperature. Yes, so now here the grains here, okay, that video, okay, so after rolling, what happens is the grains become very much refined. All right, now this is nothing but a 2D schematics of a rolling process. Okay, and let's say that the initial thickness here is H0. All right, and the final thickness over here is H1. So what we are doing in rolling, we are reducing the thickness. Okay, reducing the thickness of a workpiece. All right, that's what we are doing. All right, plus we are also making it stronger. Okay, we are also making it stronger, guys. Yes, do you agree? Okay, because here we get a finer crystal structure or a grain growth, something like that. All right, so because of this finer grain growth, we are making it stronger. Okay, so yes, so let's say that Okay, let's say that we have initial thickness as h0 over here and the final thickness as h1 over here. Okay, so and let's say that okay, let's say that here at this point the velocity is again v0, and let's say that at this point where it's coming out, velocity is v1. Okay, now let me write it. So v0 is initial velocity, okay, and v1 is final velocity over here. So let me just get rid of this so that I make it a bit better, right? Okay, so let's say that this is h0 from here to here. Okay, so initial velocity, final velocity. So what we say here is that v1 is greater than v0, right? v1 is always greater than v0 or v0 because the area of cross section decreases, all right? So area of cross section decreases here, guys, all right? Is it good? So v1 is always greater than v2 because the area of cross section decreases. Are you getting that? Yes, because there's a relation, something like that, right? A into v equals to constant, something like that, right? Okay, so okay, so let me write it over here. Okay, let me just write it over here. So v1 is greater than v0. This is what we say. Okay, because the area of cross section here is decreasing, that's why the velocity is increasing over here. Are you getting that? Hello, are you getting this, guys? Yep. Okay, so yeah, I'm not getting the feed. Okay, right? So let me see if I can get the feed. Okay, so yes, a very good evening Nitish, Preeti Rani, very good evening Mayank, Chaitanya, Sanjeev. Yes, I'm getting it now. Okay, yes, Nitish Kumar, yes, you are welcome. Okay, so yes, good to see that. All right, so area into velocity equals to constant. That's why if area, so velocity is inversely proportional to area here, right? It's kind of that, isn't it? So v1 is always greater than v0, that's why we say it. Okay, so v1 is always greater than v0. All right, now this relationship, okay, so let's say that we have h0 from here to here. Okay, we have h1 from here to here, and we have this velocity v1, and at this point of time this is v0, initial velocity and final velocity. So we are saying that h0 upon h1 is nothing but v1 upon v0. Okay, please note all of this, guys. Okay, v1 upon v0. Is it good? So this is one of the relationships that you need to have. All right, is that good? Yep. Now let's talk about okay, now let's talk about this thing. Okay, so okay, now there's something called a neutral point or a neutral zone. Okay, and at this point the velocity of strip, strip means this, okay, velocity of strip means the workpiece. Okay, so workpiece equals to velocity of the roller. All right, what is the velocity of roller? That is v equal to r into omega, right? So that I can write something like this, r into omega. Okay, R is nothing but d upon 2 into omega, right? So this is what we have. So please please note this point, all right? So that's what it is. Are you getting this? So velocity of strip means velocity of workpiece at this neutral point or neutral zone is nothing but velocity of the roller, that is nothing but r into omega, that is d upon 2 into omega, right? Omega is the angular velocity here, right? So what is d? D is the diameter of the roller, as you can see over here, right? D is the diameter of the roller. So d equals to dia, omega equals to angular velocity, right? You guys getting this? Hello? Again, I have the same issue. Not getting the feed. Again, you know, the feed thing keeps happening here. Okay. Okay. Is that good, guys? Yep. Are we good here? So let me tell you that we have very interesting questions at the end of this video, but obviously we have to take some formulas over here, right? So that we go there with new energy, okay, and new understanding. All right. Yep. So W is angular velocity in radians per second over here. Okay. Is it good? Yeah. Now let's come to another discussion over here. Okay, fine. So the distance from here to here, okay, and let's say that we have, if we join these two centers over here, okay, let's say this angle is alpha. So alpha is nothing but bite angle, okay. Is it good? So alpha is nothing but the bite angle over here, and this distance, let's say that this distance A into C, okay, this distance is called, so the distance is nothing but, you know, the length of deformation zone, okay, length of deformation zone, all right. That's why it is, because, okay, why deformation zone? Because at this zone over here the deformation is taking place, okay, not that zone actually. So this zone, this red zone is nothing but deformation zone. Are you guys getting this? So that's called a deformation zone, okay. And AC is length of deformation zone, that is given by under root of R into delta H, okay, where R equals to D upon 2, all right. Now this is the diameter of the roller, okay. Now radius, this is the radius of the roller, all right. R equal to D upon 2. So let me just write it, radius of the roller, okay. That's nothing but radius of roller, guys, okay. Okay, so that's nothing but D upon 2. Now what is delta H? Delta H is thickness reduction, okay. So that's called thickness reduction, all right, and that is given by H0 minus H1, okay. Are you guys writing all of this? H0 is this one, okay, initial thickness, and H1 is final thickness over here, all right. So H0 here is initial thickness, and what is H1? H1 is the final thickness. Okay, so if you don't know how do you visualize S0 and H1, this is something like that. Okay, so H0 is this height over here and H1 is this height. Is it good? Now a bit of theory, guys. All right, now we'll jump straight away to the questions here. Is it good? Hello? Is it good? Okay, fine. So now maximum reduction in thickness. Okay, it also has a formula. In thickness is given by mu square into r. So please note all of this. We will talk about this. All right. Yes, Nitish Kumar, you're right. So HF minus H0, okay, or H0 minus HF, because H0 is more than HF. All right, Nitish. So maximum reduction in thickness is nothing like this. Okay, it's given something like this, that is delta H max equals to mu square into R. Are you getting this? So mu here is coefficient of friction. Okay, mu here is coefficient of friction and R is radius of the roller. All right, now there's one more thing. Okay, for rolling to take place, there's just one condition, guys. Okay, that condition is alpha. What is alpha? That is the bite angle or the deformation angle. Okay, so that is nothing but the bite angle should be less than equal to beta. Okay, so what is beta? Beta is nothing but angle of friction, or just write it something like this. So friction angle. All right, and that is nothing but tan inverse mu. Is it good? So alpha bite angle should be less than equal to beta, where beta is friction angle. All right, so that is given by tan inverse mu. Is it good? Now mu is nothing but coefficient of friction. All right, now let's jump to our first question. Okay, the initial velocity of strip is dash 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 dash, then final velocity of strip. We talked about it, right, guys? So you just need to tell me the answer of this first question. Okay, the initial velocity of strip is dash 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 dash, then final velocity of strip. Come on. Now comes some interesting part over here. Okay, now we are doing questions. So what do you think? Chaitanya says it's A. So initial velocity is lesser than final velocity, it says. So here we talked about here, right? We talked about this thing, that V1, obviously here, V1 is the final velocity and that is greater than V0, isn't it? Here we talked about it. V1 is always greater than V0. So initial velocity is what? Lesser than? Yes, so initial velocity of strip is less than the final velocity of strip, right? Because V0 is less than V1. So Hiten, yes, you're right. So we are talking about questions here. Okay, so A is the answer here. Initial velocity of strip is lesser than final velocity of strip. Yes, you're right, Sanjeev Kumar. Yes, good, well done. Now the next question. Good, guys, good. To avoid bending. Okay, now let's talk about this bending thing. Okay, we have not talked about bending yet, but yes, let's talk about bending here. Okay, now, so to avoid bending, of a sheet, okay, to avoid bending of sheet, okay, the velocity of the rollers should be equal, all right? Let's say that V1 and V2 is the velocity of both the rollers, okay? So V1 equals to V2, all right? Is it good? Now these are what? These are tangential velocities. So tangential velocities must be same. Right? So what it means? V is nothing but R omega, right? So V is nothing but, okay, let me say, so R omega 1 equals to R omega 2, where R is the radius of this roller, right? R is the radius of this roller and R is also the radius of this roller, right? Isn't it? So what it means? So what it means is omega 1 should also be equal to omega 2. Now omega is what? Omega is angular velocity. Angular velocity in radians per second, right? Is that good? Hello. So omega is nothing but angular velocity in radian per second, right? Now what is omega? That is 2 pi n1 equals to 2 pi n2, right? So what it means is, okay, let me write it over here because it's overlapping, right guys? So I'm going to just write it here. So 2 pi n1 equals to 2 pi into n2, where n1 and n2 are rpm, right? Because omega equal to 2 pi n1. So what it means? So n1 equals to n2. Isn't it? So n1 equals to n2, omega 1 equals to omega 2, v1 equals to v2. Now these are the conditions over here. Are you getting this? n1, n2 are rpms here, all right, revolution per minute. Okay, now please do this question. To avoid bending, what should happen? The angular velocity of both the rollers must be same. The RPM of both the rollers must be same. The tangential velocity of both the rollers must be same. Which one of these is correct? Is it A? Is it B? Okay, so Hithane. Now let's say that if this is bigger, right? And okay, so Hithane, you're saying that, okay, so is okay, let's say that this is bigger over here, and let's assume that omega is same, so this velocity is going to be more here, right? At this point of time it's going to be more and it's going to be less. Here the velocity is going to be less, here the velocity is going to be more, right? If this roller is big enough. It will move. So yes. So Hithane, yes, intuitively it's coming, yes, it should be bending upwards, all right? Yep, so it should be bending upwards. Okay, fine. So what do you think about this? So angular velocity of both the rollers must be same. Yes, that is true. RPM of both the rollers must be same. That is also true. Tangential velocity of both the rollers must be same. So it's C over here, right? 1, 2 and 3. Are you getting this, guys? Hello? Is it good? Is it good? So there are so many things there, right, to avoid bending. But we are here talking about bending in this plane right now, okay, Nitish? We are here talking about bending in this plane only, okay? It can also be in other planes as well, right? So we are just talking about bending up and bending down here. Is it good? Yep. Now the next question, okay, now H0 is 50 mm and yeah, we do, Hithane, we do make shells using forming, right? But we use 3 rollers instead of 2. okay, that we do. Okay, again we'll talk about it in next series, okay, next sessions. Now fine, yes, we do that, Hiten, yes, you're right, but we use 3 rollers. All right, rollers are something like this. Then a sheet is pressed like this, okay, it's put like this, so we just are able to make shells, okay, depending on the distance between these 3 rollers. Hiten, all right, it is possible to make shells, but yes, using 3 rollers at least, okay. Now here's what we are given is H0 is 50 mm initial, okay, and H final is 40 mm, okay. So I'm going to just use the same notification that we have been using, right? So H1 is again 40 mm, all right. Now given the coefficient of friction, so mu is given to you something like that, 0.2. So diameter of rollers is also given to you like this, so 200 mm, okay. So number of passes required is, so number of passes required is what? Sridhar Gupta, to you, let me tell you that no, this is not very much sufficient to clear GATE, all right. Your efforts also count, right? What about your notes? What about your belief, isn't it? What about your preparation, right? So that's what it is. Okay, fine. So Salahuddin says that answer is C, okay. So fine. So how do we, so okay, now what we say is thickness reduction required, okay, thickness reduction required. How much is the thickness reduction required here? That is H0 minus H1, right? So that's nothing but 50 minus 40 mm. So this is how much? 10 mm, right? Sanjeev Kumar, okay, let's see. I think you're right, okay. Those who are saying C, I think they are correct, all right. So let's see. Now thickness reduction required is 10 mm, okay. Now let's calculate this maximum thickness reduction possible. The maximum thickness reduction possible is how much? Reduction possible equals to how much? That's mu square into R, right? Isn't it? So maximum thickness reduction possible is mu square into R. So that's nothing but 0.2 square into what is R? So D is 200 mm. So radius is 100 mm, right? So R is 100. So this is how much? How much are you getting this? So this is 0.04 into 100. So that is nothing but 4 mm, okay? So in one pass, you have 4 mm. Okay, so this is nothing but 4 mm per pass, all right. Mu square R per pass. Okay, so number of passes required is how much? Let's say n equals to number of passes. So that should be 10 upon 4, right? So that is 2.5. So obviously we will not be able to complete it in 2.5. So what should be the answer? Hiten, yes, you're right. So number of passes cannot be 2.5, right? So what should be the answer here? So it should be 3, right? So 3 is the correct answer, right? Are you getting this? So minimum number of passes has to be 3. Hello, is it clear to you? Just type in I if this is clear to you, okay? Because I told you, right, the maximum thickness reduction here. We had a discussion about that, right? So what is that? Mu square into R, this one, right? So we talked about it. Maximum reduction in thickness is mu square into r. So in one pass, how much maximum reduction it can take? So that's 4 mm here. I hope that you're getting this, okay? That's 4 mm. Now, required thickness reduction required is 10 mm, right? So how many passes? So 10 upon 4, so that is 2.5, but it cannot be 2.5. So it has to be 3, right? So that's where it is. Next question, guys, okay? Now, how many of you got it correctly? 3. Just type in I want to see your names, okay? How many of you guys got it correctly? Come on. Okay, now the next question. Now this is the next question, okay? So this is the next question. Okay, Devarshi, Salahuddin, Nitish Kumar, Sanjeev, Sridhar. Okay, good guys, good. So I think 5-6 guys over there, right? Devarshi again and Sanjeev Kumar. Good guys, good, impressive. Alright, so what we have here is, these are the information that is given to us, okay. Alpha is also given to us, that is 2 degrees. Coefficient of friction is nothing but 0.2. The final strip velocity after rolling is, right. So if alpha is given to you, or mu is given to you, can you find, what can you find? Okay, so always, even before starting, just try to find if rolling is possible. Okay, this is the hint here. If rolling is possible. Okay, so just check if alpha is less than equal to beta, or alpha is less than equal to tan inverse of mu, right? So this is what we talked about, isn't it? Where alpha is the deformation angle, right? So alpha is the deformation angle, and mu is what? Mu is coefficient of friction. Okay, now what is beta? Beta is what? Friction angle here, right? Alpha is deformation angle, mu is coefficient of friction, beta is friction angle, right? So is it happening? What? Is this happening? Alpha is less than equal to tan inverse mu. Is it happening? Because this is the condition if rolling is possible, right? So let's say that, check if alpha is less than equal to tan inverse mu. What is alpha? 2 degrees. What is tan inverse 0.2? How much is this? So is it happening? 2 degrees less than equal to tan inverse mu. So what is tan inverse mu? That is 0.2, right? So that's 0.197 degrees. Is it true? So this is 0.197 degrees, right? How come is it 11.3? Arre, this mu isn't radians, alright? Just mu is in radians, okay? So this is 0.2 radians, this is not degrees. So tan inverse 0.2, I am getting it as 0.197. So this is not happening, right? Just calculate it once more, guys, okay? So this is not happening. Are you getting this? Yes, exactly, Devarshi, you're right. Okay, it's 0.197. So this is what? Is it in radians or in degrees? Again, you know the confusion, right? Are you getting this? So tan inverse 0.2, okay, this again is in radians, right? This is not in degrees. So that's 0.197 radians, isn't it? Yes. So how much is 0.197 radians? If you convert this to radians, how much is it coming, right? So how do you convert into radians? So pi into radian equals to 180 degrees, right? Isn't it? So 0.197 radians, 0.197 radians equals to how much degrees? 180 upon pi into 0.197 degrees, right? Hello, so how much is this you're getting? That's 11.29, right? Yes, you're right. So this is nothing but 11.29 degrees, right? So obviously it's satisfying, right? So this is nothing but 11.29 degrees. So we are good, right? Yep. So the final strip velocity after rolling is, yes, so 11.3. So we are good. So it means that rolling is possible. Isn't it? Okay. Now using these information, okay. So final strip velocity after rolling. So can you please find out the final strip velocity? Is it possible to find out V1? All right. Now we are given, yeah, just one is very much fine. All right. So we are given H0, we are given HF, we are given angle of deformation, and we are given coefficient of friction, all right? So is it possible to find out the final strip velocity after rolling? So what we are talking here is V1 equals to how much? Is it possible? Come on guys, can you please try to find it? Now there's something like this, right? So what do we have? So H0 upon H1 is what? V1 upon V0, right? Is this that we can use? We can use that, right? So H0 is what? 200 upon H1 is what? 100, right? And this is V1 upon V0, right? So what we have is V1 equals to twice time V0. So one relation we have gotten here. Isn't it? Yes. So V1 equals to twice of V0 here, right? Are we getting it? Yes. So what we have here is, so what else can we do? So V1 equals to twice of V0 over here. What else can we do over here? Can anyone try to find it? This is one of the relationship. Now there's another relationship, tan alpha equal to under root delta H upon R, all right? So this is another relationship that we have, okay? All right, now alpha is given to us. Alpha is how much? Angular deformation, that is 2 degrees. So tan of 2 degrees is, what is delta H? Delta H is 200 minus 100. 200 minus 100 upon R, right? We can calculate R using this, right? So how much is the R here? How much is R? So Chaitanya, okay, have you found, okay, you said that, okay, this is 6 meter per second, right? So how have you found out this? Can you please tell me, or others? So could you find this 6 meter per second here, right? So R, we can find it out here, right? So alpha is in radians. No, this is in degrees here, right? Alpha is given to you in degrees. So no angular velocity required. So Devarshi, can you please tell me? So angular velocity, you are saying that, okay? Okay, so alpha. Alpha is in radians, okay? Radius. Alpha, you are saying. Arey nahi re. No. That doesn't seem to me, all right? So what I would write is, okay, this data is insufficient. I don't think that, you know, we can do it using this, all right? So data is insufficient here to calculate V1 and V0, okay? So that's D, it should be D here, right? Are you getting that? V equal to R alpha, that is for the roller, okay, Chaitanya. V equal to R into, okay, R into omega, right? That is for the roller. It is not for strip, right? Are you getting this? So D should be the answer here, okay? None. Yes, but where is omega? Omega should be given for the roller, right? Chaitanya, are you getting that? So R obviously can be found out, right, using this, or you can also use some other relationship, right? For example, this one, okay. But using this, you can find always the value of R here, right? Are you getting this? Yep. Is that good? Devarshi, actually, you know, even if you just say that it's a biaxial compressive, okay, it's a normal force that you're giving it to it. So normal shear stress, normal stresses also give rise to shear stresses, right? We always have shear stresses because of normal stresses as well, right? Devarshi, now you tell me what should be it. Okay, ठीक है. So data is insufficient, so answer is D here, right? Now please tell me this. Now, given the frictional force to the strip is 10 newtons, normal force is 10 newton, the net force acting on one of the rollers is, so even before that, let's go back, okay? Even before that, let's do this here. All right, so what is given to us here is that here, okay, let's say that here, the friction force is like this, okay? So let's say that friction force is like that, or the tangential force is like that, okay? And a normal reaction is like that, okay? So T is the tangential force, okay, tangential force. All right, and N is what? N is the normal force, right? Isn't it? So T is the tangential force, N is the normal force, all right, and they are acting at perpendicular angles to each other. So what should be the resultant force here? So resultant force should be what? T square plus N square, right? Because they are perpendicular. Are you getting that? Are you getting that? Yes. So obviously, if there's, let's say, purely compressive force, like we always have a shear stress associated with that, right? So R should be equal to T square plus N square. Do you agree to this? Hello. So what is happening here is that this T and R, okay, tangential force is nothing but the frictional force here. All right, and N is the normal force here. So resultant here is given by T square plus N square, right? Hello, because they are perpendicular to each other. So what should be the answer here? Net force acting on one of the rollers. So friction force T, let's say, is given to you 10 newtons. Okay, and the normal reaction is given to you 10 newtons. So what should be the net force? R. Can you please find it? Come on, guys. Are you getting this? Okay, fine. Yes, so R should be what? It should be T square plus N square, right? So that's nothing but 10 square plus 10 square. So that's nothing but 10 root 2, right? So it should be closer to B, okay? So it should be around 14.1. Right? So B is the answer, guys. Anurag, yes, you're right. Okay, good. Well done, guys. Is it good? Hello? You guys good there? Okay, now let me tell you that today the questions were a bit tough, okay? Hiten, yes, so it has to be B, okay, because these are two perpendicular force acting here, right? Let's say that this is T, this is N. So the resultant here is what? Under root of T square plus N square, right? Because it's a perpendicular triangle or a right triangle, right? Not a perpendicular triangle, but a right triangle. Is that good? Hello? Yep. Fine. So we are done for today, guys. Okay. Now at the same time, I'm going to see forming part 3, and even before that, I'll come back at 2 p.m. concept on fingertips. I hope that I added some value to your life, guys. All right? Okay, Chaitanya. Actually, these were really tough. Okay, I have made these questions of my own. Okay, now please note this question. Go back and do this. Yeah, exactly, Chaitanya. Exactly. For example, steel. Right? Steel goes through so many processes, right? Hardening, annealing, and so many processes, right? Heat treatment. Okay, let me just write it. Heat treatment. Okay, so steel goes through heat treatment, then it becomes stronger, right? So this is same here. Okay, if you're not struggling, if everything is very easy to you, you're not going to grow, right? So that's where it is. Now please share guys this video, all right, and also subscribe to our channel, and also keep on liking these videos if you liked it, if you like them, and if I added any value to your life. Okay, just that's where it is. Okay, all right. Okay, Sanjeev, Hiten, I have told you, right, whenever there's abnormal stress out there, and it also leads to a shear stress as well, right? They are complementary everywhere. Are you getting, Hiten? Yes. So again, I'll just clarify it again and come back to you, but I believe that this should happen, all right? So a combination of both, Hiten. So this is what I think, all right? Now, okay, fine. So please do this question. Okay, this is another very challenging question, especially part B here. Okay, and if you don't get this, I'm going to tell you this question tomorrow. Okay, so Chaitanya says it's 1 millimeter per second. Okay, so this is nothing but 1 meter per second. Yes, you should be getting it as 1 meter per second, and to what I remember, I think it should be 1.9 meter per second. I might be wrong, but yes, close to this. Okay, so 1.9 meter per second. All right, so that's where it is, guys. All right, you can take a screenshot of this. Okay, just go back and try to do this question. Okay. Yeah, Hiten. Okay, but yes, if it has discrepancy, I will tell you tomorrow. Okay, if the thought process is not right, maybe there are some assumptions, so many assumptions out there, right? So many things, but that's how it happens in real life, right? So yes, Hiten, I'm going to see you again tomorrow. Okay, so but please do this question. Okay, especially this B one. It's really interesting and it's really tough. Okay. Yep, so we are going to meet again tomorrow. Yeah, Chaitanya, please do that. Okay, so forming part 3, same time. Okay, 9 p.m. Till then, keep on sharing these videos if I added any value to your life. All right, and yes, we have a target gate batch 2 2021. You can start a free trial with us. Okay, and we have 500 plus hours of live classes, and these are the quick specification about the course. Okay, and you can also contact us at this number or put up an email at this number, right? Yep, so 60 plus gradients in top 100. This speaks of our achievement, guys. And my name is Rahul KANYAL, and I'm going to see you again tomorrow with more interesting questions. Okay, and till then, keep on subscribing, liking and sharing, and yes, thank you very much. Okay, thank you very much. Take care of yourself. Okay, and keep on washing your hands, keep on believing in yourself. Okay, and let me tell you that again, that example, right? Steel, always remember something about steel, right? It goes through heat treatment. Then only it becomes stronger, right? Always remember that. Okay, always remember this. So with this thought, I'm going to see you again tomorrow. Be blessed by the divine. All of you do really good in your life. Thank you very much.